Hello students and welcome. This is Dr. Sirme. For today I want to take you through how to balance a chemical equation, because without balancing a chemical equation, any equation you've written, it's null and void. It's not going to score marks. If for example it's a national exam or any other exam, actually you rather miss the state symbols than fail to balance the chemical equation. Maybe you ask yourself, why? Why do we balance a chemical equation? That's a big question you should ask yourself. Balancing of chemical equation, an idea that gives students very hard time. For instance, if I have the following, I have hydrogen burning in oxygen to give me water. That is a chemical equation. Remember, you can just argue. This is a very simple equation. You can argue loud. Hydrogen, there are two. There must be two. The atoms must be two on the other side. Oxygen here, there are two. I must see two on the other side. And remember what you do. You are supposed, for instance, this one, the ordinary balancing. If I have two here, I must make them two. And remember, it is not putting it here. I cannot put it there because I'm destroying the formula of water. So we do balance chemical equations by attaching whole numbers before the formula or the chemical symbol of the element or the compound. So like for this one, oxygen, there are two, they must be two. And that means I attach a 2 there. By doing that, now hydrogen, there are 4. I do the same on this side. And by that, I have balanced that chemical equation very simply. However, I want to show you a different method of balancing. Remember, we are just attaching whole number before the formula of the compound and the elements. So I can have some letters here, yes, to represent those numbers. So I all need to establish the ratio A to B to C. A to B to C. Now look at this. Hydrogen on this side, it is 2 times A. So 2A. On the other side, hydrogen must be 2C. 2 times C. The number of hydrogen. So they must be equal. That is my equation number 1. Oxygen. On this side, they must be 2 times B, which will be equal to oxygen on the other side must be equal to C. Now I can be able to establish this ratio. How do I do that? A remains to be A. I need to represent B in terms of A. Look at equation 1. Okay? Actually, I can start with any. I can even start with C. Like in this one, I have 2A equals to 2C. Divide by 2, divide by 2. A is the same as C. So that means even here, C, it is the same as A. Now, I can now establish B. Look at this second equation here. 2B is equals to C. But C is the same as A. So then I divide this by 2, divide this by 2. By doing that, I have B is a half of A. A half of A. So this is a half of A. I just need to put this ratio in the simplest form. So all I can do, I can multiply by this 2 over A all through. By doing that, this will be 2A over A, which is 2. Then I have this one. This one, 2 and 2 will cancel. 1 A and A will cancel. This is 1. Then over here, it will be 2. And that means A is 2. B is 1, which I don't need to write. Then C is 2. The equation is simply balanced. This method requires a student to be a friend of mathematics, to be in love with mathematics, especially algebra. Okay, the second equation that I wish we balance is the equation where sodium reacts with chlorine gas to produce sodium chloride. Again, I can attach the whole number here in terms of ABC. Good. And with that, we are trying to establish a ratio A to B is to C, where A, B, C are whole numbers. With that, I have sodium. I also have chlorine. Now, I can argue out. Sodium on my left hand side, it is 1 sodium atom times A, so A of them must be equal to 1 times C, so A is equal to C. Then with chlorine, it will be 2 times B, 2B is equals to 1 chlorine, or rather 1 times C, so it equals to C. Having done that, now I can get the ratios. I am trying to find this ratio. A will just remain to be A. Okay. A is the same as C. So it is the same. It is A. And then I can use equation 2 here such that 2B equals to C. And remember, C is the same as A, equals to A. So with that, I can have divide by 2, divide by 2. And that means B is a half of A. So it is A over 2. So with that, I can now multiply by 2 over A. What exactly I'm trying to do is to eliminate the A's and of course the numerator, the denominator here. So this one will be, if you multiply, if you open the bracket, this automatically will be 2, good. And then this will be equals to 1, and this one will be equals to 2. Good. Now I have the ratios. This is 2. This is 1. If it is 1, it's not a must you write it. And this one, it's 2. And with that, the equation is very well balanced. Good. 2 sodium, 2 sodium. 2 chlorine, 2 chlorine. And that is example 2. Okay, this is the next equation. Kindly stop the video and try to balance. The next equation I wish to balance using that algebra method is where lead-2 nitrate is heated and it decomposes to give you lead-2 oxide, then nitrogen 4 oxide and oxygen. Again, I attach my letters there, A, B, C, D. Then I start adding out. Remember, I have lead atoms. I also have the nitrogen atoms. I have oxygen atoms. Yes, I have the 3 types of atoms. My aim is to establish the ratio A to B to C and to D. Okay, lead atoms, A. It is A of them, equivalent to B. A is equal to B. I have no problem with that. Then I have the nitrogen. Nitrogen simply will be, already it is 1 times 2 times A. So it is 2A. That is 2A equals to, that is nitrogen. That's nitrogen. It's just 1. It is 1, yes, times C. So equals to C. That's the next equation. Then we have the one for oxygen. Already this is 6. 6A. That is 6A is equals to, in this other side it will be oxygen. Over here there is oxygen, there is oxygen, there is oxygen. So it will be equals to B plus, yes, 2C plus 2D. 2D. Good. I'm ready now to represent the ratio A, B, C, D. And that will be A is 2. Good, I have A. Then B is the same as A. So, again, the B will be A. That's why I've written A. Then C. I want to represent C using A. Okay? And you can see it here. C is 2A. So instead of C, I write 2A. Now, with that, I can now represent D. D. With that, I have D here. So I can replace what I know. 6A equals to B, which is the same as A, plus 2C. Okay? 2C. Remember, C is 2A plus 2D. So having said that, this is 6A. Over here, I have 4A, 5A. So I subtract from this side. 5A equals to 2D. So this is A. In that case, it will be A, this A equals to 2D. So with that, I can now divide by 2, divide by 2. And that means D is 1 over 2A. That is a half A, like that. So what I need to do there is to multiply by 2 over A. Why do I do that? To eliminate the A's and to eliminate a denominator somewhere. So I open the bracket one at a time. So if I open the first one, remember that is 2 over A times A. That will be 2. Then I have this one, again will be 2. Then I have this, it will be 4. Then over this, it will be 1. I can now replace my values. This is 2. This is 2. This one is 4. And this one is 1. Good. Can I confirm that my equation is now balanced? Lead atoms, 2 of them. 2 on this side. And nitrogen atoms, 2 times the one there, it is 2. 4 of them. You can see there are 4. Then oxygen, 6 times 2, 12. This is 2 plus 8, that is 10 plus 2, 12. Example 3. Okay, this is the next equation. Kindly stop the video and try to balance. Example number 4 of an equation that we wish to balance. Again, this is A, the B, C, and D. Our aim is to find A, B, C, and D. Good. This is sodium peroxide reacting with water to give us sodium hydroxide and oxygen gas. Now, we start with the first element, sodium. Sodium, 2 times A. 2A on the left-hand side equals to C. Just 1 times C equals to C. That one I have. Then I can talk about oxygen. Over here, I have 2A, yes, 2A plus, because there is another compound here with oxygen, so plus B, 1 times the B, equals to, oxygen on the other side equals to C, yes, it is 1, then 2 times D, plus 2D. Good, that one is done. Hydrogen over there, I have 2B equals to, that's hydrogen equals to C. It is the only one there. And I'm done with the 3 types of element here. We have sodium, oxygen, and hydrogen. The aim is to come up with A to B to C to D. Remember, A is just A. Now I want to represent B in terms of A. If it is not very possible, I can go to maybe another one that is easy to work out. For example, I can start with C. Yes, I can start with C. If you look at this one, C is 2A. So wherever there is C, I can write 2A. I have no problem with that. I'm good with it. Now, I can now look at what I have. Like this one. Already I have C. So 2B is C. And what is C? It is 2A. What exactly am I trying to do? I'm trying to represent all the other ratios in terms of A. Like in this one, divide by 2, divide by 2. We are saying that B is the same as A. So even this one is A. Then we go to D. You know, we can work out D. You can use this. What do I know? I know 2A plus B, which is the same as A. No, B is the same as A, equals to C. Do I know C? Yes, it's 2A. Then plus 2D. This is 3A minus 2A equals to 2D. With that, I can say A is 2D. I want to represent D in terms of A. Divide by 2, divide by 2. So simply D is a half A. A half of A. So this is a half of A. So what do I need to do again? I multiply here by 2 over A. If I do that, the first one, if I open the bracket, this will be 2, this will be 2, this will be 4, this will be 1. So can I now see what has happened? This is 2, yes, this is 2, this one is 4, and this one is just 1. Now let me confirm that the equation is balanced. 4 sodium, 4 of them, okay? 4 hydrogen here, 4 hydrogen here. It's good. Then I can talk of oxygen. Oxygen, I have 4 plus 2, 6. So that is 4 plus 2, 6. Well balanced. If you practice this method, it becomes very easy, especially for equations that have more than 3 elements, or rather 3 and above, or it has a number of elements. Okay, this is the next equation. Kindly stop the video and try to balance. The next example of a chemical equation that we wish to balance is what I have. As usual, I can attach A, B, C, and D. My aim again, to establish that simple ratio. A remains to be A. Then we have hydrogen, one of the elements. I have chlorine, I have oxygen, I have phosphorus. Good. I can now go one element at a time. Hydrogen times A, that is A. Then there's no other hydrogen on this side, so I can equate to what is on the other side. So it is 3C. So 3C. Good. Now I can go to chlorine. Chlorine on this side, it is just 1 times A. So it is A. There's no other chlorine. Then I can go to the other side, equals to 2 times D. So it is 2D. Okay. Then I go to the next. I can talk about oxygen. 4A. That is 4A. Okay, plus 10B. 10B equals to, on this other side, 4 times C. 4C. Plus, on this other side, 7D. 7D. That's the other equation. If I talk about phosphorus, 4 boy. 4 times B is equals to, there's no other phosphorus, it is just 1. Is equivalent to 1 times C, that is C. And there's no other phosphorus there. So I can go ahead to solve. If I can start with what I know, A is A. Look at this one. A is 3C. So I want to represent C in terms of A. Simply it will be, I divide here by 3, I divide here by 3. A over 3 equals to C. So C here is A over 3. If I want to talk about D here, it will simply be, I divide by 2, I divide by 2. So A over 2 is equals to D. So even D I have, it is A over 2. A over 2. All I have now is B. I can use this equation. 4B is C. Do I know C? Yes. I know C is A over 3. So I want to eliminate this by 4 divided there, by 4 divided there. So that tells you that B, yes, B is the same as A over 12. A over 12. So this is A over 12. So if that is the case, again, I want to eliminate A and the denominators. Denominator, the best way to eliminate, multiply by the highest factor there, or the LCM of the denominators. So this will be 12 over A. If I'm doing that, this will be 12. Yes, this one would be 1. Okay, if I talk about this one, remember it is divide by A, divide by A. By 3, 1. By 3, 4. So that is 4. Then this one will be by 2, 1. By 2, 6. By A, 1. By 2, 1. That is that. So I have the ratio. This is 12. Then this is 1, which I don't need to write. This is 4. And this is 6. Just to confirm, remember this is one you can do it very roughly on a rough space, and you'll have it well done. The balancing is what matters. We have hydrogens, 12 of them. 12. You can see 3 times 4, 12. Chlorine, 12 of them. Yes, 6 times 2. 6 times 2, 12. Then oxygen, 12 times 4, 48. 48 plus 10, 58. 58. So this is 16. Yes, 16 plus 42. That is again 58. Equation well balanced. An equation that was a bit complicated. Once you get used to this method, it becomes very easy to balance the equation. Okay, this is the next equation. Kindly stop the video and try to balance. Example number 6 of a chemical equation that we wish to balance. Again, A, B, C, and D. The ratio A, B, C, and D. Good. With that, A remains to be A. So we represent B, C, and D in terms of A. Now let's go element after another. Carbon. Carbon. It is 3A. Yes, 3A is equivalent to C, because there's no carbon in the other. Then we talk about hydrogen. 8A. Yes, 8A is equivalent to 2D. Yes, 2D. Then we go to oxygen. Yes, oxygen. 2 boy, so 2B is equivalent to oxygen. Now this will be 2C plus D. 2C plus D. Good. With that, I'm going to represent. I can even start with C. C is 3A. So automatically, instead of C, I write 3A. After doing C, then I can do dog, the D here. The D is given by 2D is 8A. So what do I need to do? I want to represent D in terms of A. So I divide by 2 on both sides. So D will simply be given by, divide by 2 here, divide by 2 equals to 4A. So this means it is 4A. Having done that, I'm good to do B. 2B is equivalent to 2C, yes, 2 times C. I know C is 3A. Then plus D, which I know it is 4A. So with that, 2B is 6 plus 4, 10A. I can divide this by 2, divide by 2. It means B is 5A. 5A. Good. Having done that, this is 5A. So what I need to do is to divide by A all through. I divide by A all through. This will be 1, this will be 5, this will be 3, and that will be 4. Good. I'm going to represent. That is 1. I don't need it. This is 5. Yes, this one will be 5. This is 3, and this is 4. Can I confirm that the equation is balanced? 3 carbons, 3 carbons. 8 hydrogens, 8 hydrogens. Okay? 10 oxygen, 6 plus 4. Done. Okay, this is the next equation. Kindly stop the video and try to balance. Equation number 7 that we are trying to balance. Sodium hydroxide. Remember, this is concentrated and hot sodium hydroxide reacting with the chlorine. Sodium chloride is a product. Sodium chlorate and water. So this is A, there is B here, there is C, there is D, and there is E. My aim is to establish the ratio A, B, C, D, and E. I go element after another. Sodium, it is 1 sodium in this formula, so times A, we talk about A is equals to, on the other side I have sodium, there's 1 here, there's 1, so it is C plus D, C plus D. Then I can go to the next, oxygen. Oxygen, there is 1 here, so that is A, equals to, there is oxygen 3D, yes, 3D, plus, there is only 1, so it is 1 times E. I have that. I go to the next element, hydrogen. Hydrogen, there is 1 here, so it is A, 1 times A there. There is no other hydrogen here, so I go to the other side. There's no hydrogen, there's no hydrogen, so hydrogen is there, 2E. 2E. Good. I can go to the last one here, the chlorine. Chlorine, there is 2 times B, 2B. Yes, 2B equals to C, and then there is D. So C plus D. If that is the case, I can now start establishing this ratio. This is A. I look at it, which is the easiest to work out, like the E. It's very easy to represent E in terms of A. Divide by 2, divide by 2. So we are saying that E will be the same as a half A. This is A over 2. Having done that, I can consider the whole of this. That is C plus D. It is the same as this. C plus D. According to the equation, this one is equals to A. So I can have this 2B is the same as A. Just establishing by this. So I can state here that divided by 2, that B, boy, is the same as A over 2. A over 2. That I can use this one. A equals to 3D plus E. Do I know E? Yes, it is A over 2. Okay, A over 2. So this one just crosses over. This one will be A minus a half A. That gives you a half A. So it is a half A equals to 3D. So what do I need to do to establish D in terms of A? I divide by 3 here. D is simply A over 6. A over 6. A over 6. Good. We are moving because we only have C to represent in terms of A. And where is C, I can use any. I can decide to use this one. I can decide to use this one. Okay, this is 2B. Let me use the last one there. That 2 times B. Do I know B? Yes, it is A over 2. 2B is the same as C added to D. Do I know D? Yes, it is A over 6. Good. With that, I have the whole of this is A. Okay, then I subtract A over 6 equals to C. If I do 6 over 6 minus 1 over 6, it is 5 over 6. So C is simply 5 over 6 of A. So this is 5 over 6A. So with that, I'm going to eliminate the denominator and remove the A. The highest denominator is 6, so it is 6 over A. If I do that, I'm now having the ratio 6. So this is 3. Yes, by 6, 1, by 6, 1, by A, so this is 5. Good. And then this one will be 1. Then this one by 2, 1, 3, that is 3. I have the ratio there. I can simply replace the letters here with my figure. This is 6. Good. This one is 3. This one, according to the ratio, is 5. This is 1. And this one is 3. So can we confirm together that that equation is balanced? Sodium. 5 plus 1, 6. 6 oxygen here. I have 3 here and 3 here because it is the whole of this formula is multiplied by 3. Hydrogen, there are 6. Hydrogen on this side, it is 2 times 3, 6. Chlorine, there are 6. Here there are 5 plus 1. Equation balanced. However complicated it is, you can simply work it out. Example number 8. An equation that is somewhere in the survey process. And now I can go element after another. So we start with nitrogen. Nitrogen, which is 1 here, so 1 times A. So we are talking about A being equal to nitrogen on this side, only 1 equals to D. Then I go to the next, hydrogen. 4 of them times A, 4A. There is the other hydrogens here, 2 of them, so plus 2 2B equals 2 on the other side. So this is 3 times D, so 3D plus 2E. Do not be scared even when the equation seems to be longer there. Good. We go to chlorine, Cl. Chlorine is 1 here, so that is A. Yes, 1A. Then over there will be equals to 2C. Yes, 2C. Is there any other chlorine? There isn't. So it is 2C. I go to the next, calcium. Calcium. So it is only 1, so it is B equals 2. It's only 1 equals to C. I'm done with that. So I can go to oxygen. Oxygen. With oxygen, I know here it is 2 of them. So 2 times B. So 2 boy equals to oxygen on the other side. Only 1. So it is E. Having done the equations, now I'm going to represent the ratio A is to B, is to C, is to D, is to E. Remember, A is just A. Now let's think of the others that I can easily represent. Look at this. A is the same as D. So where there is D, I can also represent it with A. Good. With that, I can go to another one. A is 2C. And that means I can divide by 2, divide by 2. That C is the same as A over 2. A over 2. I'm done with that. So, if I'm talking about B here, look at this B. B is equals to C. Then this one, A over 2. Now I talk about E. I can simply use this one. It means 2B, 2 times B. Do I know B? Yes. That is my B there. 2B equals to E. So with that, this is A equals to E. And that means even here there is A. So what do I need to do? I'll multiply everywhere by 2 over A. 2 over A. By that, this will give me 2. Good. This one will be equivalent to 1. This one will be 1. This one will be equivalent to 2. And this one will be 2. So I have the ratio I can replace. This is 2. This is 1. I don't need to write it. This is 1. It remains like that. This is 2. And this is 2. Confirm with me that the equation is balanced. Nitrogen, 2 of them. On this side, 2 of them. Hydrogen, that is 8 plus 2, 10. So this is 6 plus 4, 10. Chlorine, there are 2. Chlorine, there are 2 here. Calcium, it's 1, it's 1. And oxygen, that is 2 oxygen, 2 oxygen. The next question that I wish we balance, look at it. It is having a number of elements. So trying the old method for this, it will truly disturb you. So what we need to do is to just attach the constant as we were doing. Then we try to establish the ratio A, B, C, D, and E. Good. Then we go element after another. Calcium. Yes, 1 times A, that is A. On the other side, it is 1 calcium in this formula times D, so it equals to D. Then we can talk about silicon. Yes, silicon, 1 times A, that is A. That's 1 silicon in the formula times A. Then 1 silicon times C, that is C. Oxygen, oxygen 3 times A, 3A equals 2. On the other side, we look for oxygen. It is in this formula, so it is 1 times E equals to E. We go ahead, hydrogen, just 1 in this formula, so it is B, 1 times B. Hydrogen on the other side, it is 2 times E equals to 2E. Then we have fluorine. Fluorine in this side, it is just 1, so it is B equals to, on the other side, it will be 4C. Yes, 4C because 4 times C. Then 2 times D plus 2D. Good. We are now ready to do the simple ratio A, B, C, D, E. A is just A. Now let's consider what we can easily do. A is equals to C. So even this one is A. So where there is C, I represent with A. A is equals to D. So even this one is A. What else do I know? Look at this one. E is 3A. Where there is E, I just write 3A. Now, I only have B to do. B to do. Like B, I know is 2E. What is E? 3A. So B is simply 6A. So this is 6A. The next step, divide all through by A. So if I divide by A, it's 1. This will be 6. This will be 1, this will be 1, this will be 3. So I have established the ratio. This is 1, this is 6, this one is 1, then here it is 1, and over here it is 3. Calcium is 1, it's 1 on the other side. Silicon is 1, 1 on the other side. 3 oxygen, 3 of them. Considering this is 3 molecules of water, so it is 3 oxygen atoms. Hydrogen, there are 6. On this side, 2 times 3, 6. Fluorine, this is 6, yes. 4 plus 2, 6. The equation is balanced. To take you through example number 10, again we want to balance this equation. We attach the constants there, the whole number. So we are trying to establish the ratio A, B, and C. Again we go element after another. Good. We have nitrogen. Nitrogen on this side, there are 2. In this formula there are 2, so we are talking about 2 times A. 2 times A. On this side, nitrogen, there are 2 in this formula again, times B. 2B Yes, 2b nitrogen is the same as 2a nitrogen on this other side. So we are done with that. We can go to hydrogen. So there are 4 times a. So we're talking about 4a, that is hydrogen, equals to, on the other side, hydrogen, they're here, 2c. So equals to 2c. Okay, do we have another element? Yes, oxygen. 3 of them times a. 3a is the equivalent to oxygen on the other side. 1 times b, so it is b plus c. Now, we have all the equation. Now, it's a matter of solving to establish this ratio. Remember, as we have said, a remains to be a. Let's look at this one. Equation number 1. It states that 2a is the same as 2b. So if I can divide by 2 on both sides, a is the same as b. So where there is b, I can replace with a. That is correct. Then we can talk about c. Using the second equation, 4a is equivalent to 2c. So what does that mean? We want to establish c in terms of a. Divide by 2, divide by 2. It means c is 2a. So where there is c, I can replace with 2a. 2a. What exactly does that mean? I can now have this ratio. Divide by a all through. The ratio is 1 is to 1 is to 2. So let's try to replace what we have. This is 1. I don't need to write. If it's 1, that is 1, and this is 2. So can we consider now if the equation is balanced? Nitrogen, there are 2. There are 2 on the other side. Hydrogen, there are 4. 2 times 2, 4. Then oxygen, there are 3 of them. So this is 1, and these are 2. So the equation is balanced. Equation number 10. Otherwise, the algebra approach, a very easy way of balancing chemical equations. So maybe you can try others and you practice until you perfect. Thank you so much. That was 10 good equations balanced by algebra method. Hello my students and welcome. This is Dr. Sami. And what I want to take you through today, it's a very, very important concept on how to balance chemical equations. Maybe you ask yourself, why should we balance a chemical equation? Why? Why do we balance a chemical equation? That's a big question you should ask yourself. Actually, we have a law that we call law of conservation. Law of conservation of mass. And this law states that mass, or simply matter, cannot be destroyed or created. What does that mean? If you're having the reactants, what we call the reactants, if for example I have 3 atoms of sodium, if I have 3 atoms of sodium, at the end of the story, I must have 3 atoms of sodium. I cannot destroy matter or rather mass. I cannot destroy mass. I cannot destroy or rather create. Yeah, I cannot. That's why when you're writing a chemical equation, the number of atoms of each element must be equal on both sides. That is the corresponding. If it is sodium, on the reactant side must be the same on the product side. It must be on the product side. Otherwise, law of conservation of mass. Matter or mass cannot be created, cannot be destroyed. So we need to balance a chemical equation. If you're having 1 kg wheat flour, I cannot make 1,000 buns. I cannot make 1,000 chapatis. I cannot. So I cannot create matter. I cannot create matter. Maybe one question I ask my student. When this earth was created, there was only one human being. There was only one human being. Yes, one human being. Today, maybe we are 8 billion human beings. Then you ask yourself, how comes the earth has never been overloaded? Simply because of law of conservation of mass. There is nothing new that is being created. What exactly happens? It is matter that is circulating. Maybe animals are born, humans are born, they die, get into the soil, then they are incorporated as part of the matter in the soil. And the cycle continues. So matter cannot be destroyed.